Okay, so in the previous video, we showed that this function y of t satisfied the differential equation. The next step, of course, is to solve the initial value problem. So for this initial value problem, what we want to do is we need to make sure that when we substitute in 0, we get -3 out for our value of y. So y of 0 is going to be 2 over c times e to the -2 times 0 minus 1, and that must equal -3. Well, that simplifies down to just 2 over c minus 1 equals -3. And if we do a little bit of algebra, 2 is equal to -3 times c minus 1. We're going to get 2 is equal to -3c plus 3. And that makes -1 equal to -3c. So that makes c equal to 1/3. So the y of t that we get, which solves the initial value problem, is 2 over 1/3 e to -2t minus 1. But we really don't want to keep it this way because this right here is a compound fraction. So the best thing to do is multiply the top and bottom of the fraction by 3 to clear out the fraction. And that's going to give us 6 over e to -2t minus 3. And so that is our y of t that is going to solve our initial value problem. The next thing to do now, besides rewriting it over again so we have it, I said 6 really, so again, writing it over again, we've got 6 over top of e to -2t minus 3, and now we want to find that interval of existence. And this time around, it's not as easy as before because now we have division going on in our function. So we have to make sure that we are continuous and we're differentiable. And of course, you have to be defined to be both. So the best thing to do is take our denominator and set that equal to 0 to see where we have our problems. So if we set this e to -2t minus 3 equal to 0 and solve, we get e to -2t equals 3. Taking natural logs, -2t equals ln 3. So t is equal to negative natural log 3 over 2. Now remember, that is the bad number that we want to exclude. So if we draw a number line and look at what's happening, we've got our negative ln 3 over 2. And again, that's a bad number. We do not want that to be in our function because it makes it undefined and therefore not continuous. So now we have to look at our initial condition, and we notice that we want y of 0 equals 3, which means that we want 0 to be in our interval of existence. So therefore, our interval of existence is the biggest interval that contains the initial condition, so that it's got to be starting at -infinity over here, all the way up to here, or it's going to be infinity all the way up to there. And you can figure out which one you want to avoid. You want to avoid this bad spot, but contains 0. So that means that we're going to draw a wall here and eliminate this bad part over here. And our interval of existence is going to be from negative natural log of 3 over 2 to infinity. And just as a check again, the number 0 does live in this interval. So that is our interval of existence for this solution of the initial value problem.